point is, thermocouple is good for measuring temperature at a particular point and under favorable ambient environments. That's the point. I just mentioned to you earlier today that thermocouple can measure temperature at a particular point. What about if what you are measuring temperature from is something passing in an industrial environment? Conveyor belt is carrying something away, and you must take the temperature. How will you not do it? Will you ask them to wait? Oh yeah, wait, let me connect my thermocouple. Impossible. Impractical. That is impractical. So you must look for another method. You will see another method we are going to use as we go in the notes. There's another special method for that. Now we measure the temperature. Okay, remember now, during COVID-19, when there was lockdown and partial lockdown, when you go to bank, sometimes they ask you to wash your hand, they check your temperature. Did they connect a thermometer to your mouth? Okay, they put a thermometer in your armpits, like they do in the hospital. Is that what they did at the banks and the other public places? What did they do? What did they do? Remind me. They put a what? A what? There is an infrared thermometer that you just shine the light on the forehead of that man. The light goes to your head and picks the temperature of your body. Isn't that interesting? That's what we are saying. You know you cannot use a thermometer in that instant. Put it in people's mouth or in their armpit when there is corona. You want to spread disease. So you must use another alternative, which is an infrared thermometer. A small device that can shine out a light, and you shine the light on the head of the man when the man is even standing 2 meters away. You know there was a social distance. You cannot even move closer at that point. So they shine it on your head. They get your temperature. Once the temperature reaches 38, ping, go back. They won't allow you. Is it Koro? You have Koro. You must be within 37.5 or so, something like that. Now, do you know actually that device is also used in engineering setting? That's infrared thermometer. I'll give you an example. Let's say you have a control room, a power control room here, like what we have at the ICT there. If you go into that ICT, you see a lot of batteries, right? If you are the engineer that monitors those batteries to know how they perform, you'll be checking from time to time their temperature at terminals to know whether there is a problem. You are the technician that monitors those batteries. You want to know whether there is partial contact at the terminals. How will we know if there is partial contact? What will happen at the terminals of the battery? There will be. I can't hear you. You don't know. Who knows? All of you went on 1 year industrial training. If there's a partial contact at the terminals of the battery, how will you know? Who said so? Who said so? That's the answer. That's the answer. The temperature will increase at that time. Now you have batteries of, let's say, in a large setting, you have batteries like 50 or 80. So you now go and carry thermometer at each terminal. 1, 2, and 3. And be recording it. Is that how you do it? From now to next year. You can't do it that way. And that is why such a device is produced. Infrared thermometer. You shine it at that terminal like this. Pick the temperature. Go to the next. You pick the temperature. And so on and so forth. Isn't that interesting? Isn't that wonderful? There's something else. If I want to take the measurement of this room, instead of me to carry tape rule, hold it, hold the tape rule there, measure it. Okay, what's it? Record. Hold it there. That's a device you can use to shine. If I stand here, I will shine the light to that wall, and it tells me the distance. I stand there again, shine it to the other wall, it tells me the distance, and then I multiply. Then I know the area I'm dealing with. There's another device like that.